Good morning, dear students. So, good morning, dear students. Hope I am audible.
Good morning, sir. It's audible.
Yeah, thank you. So, we'll start our today's class. Okay. So, today we'll start with module 3, and it is about internet working. Last class, last unit, we discussed about various connection issues, how to interconnect to networks, and getting connected, how to connect nodes, what are the problems while connecting, while transmitting, all those things we discussed. Now in internet working, how to interconnect two networks. So that is the concept that we are about to work about. So how to interconnect networks, multiple networks, that is a concept. Okay, in today's class, we introduce the concept about internet working. We'll discuss what is a switching, what is bridging, and how exactly a switch work, and datagram method. So there are three methods in which switching works. That is datagram method, virtual circuit, and source routing. So these three are the methods that we are supposed to understand in this particular thing. So now, considering internet working. In the previous chapter, we saw how to connect one node to another node, or to an existing network. Okay, so where we discussed about single Ethernet. And there is a very important point that you should note. Ethernet, that is LAN network, can interconnect not more than 1024 hosts. So you cannot connect 1024 hosts. What do you have to do? So beyond this, if you want computers to be connected to a network, literally it is not possible. So of course, point-to-point link can only connect it to only two, and in an Ethernet you can connect to 1024. Beyond this, if you want to connect, definitely you have to follow some techniques. That is what we see here in internet working. Okay, and similarly, wireless networks are also limited in their range. So I think through hotspot, mobile phone, you can connect up to 8 devices, and Wi-Fi systems, you can connect about 32 devices, 48 devices. So there is a limitation. So the concept of internet working, so is what interconnection of such limited networks to expand throughout the globe. So that's what we see. The concept of interconnecting different types of network to build a large global network is the core idea of internet, and of course it is often referred to as internet working. So internet working is nothing but inter means within the networks. So among the networks, how exactly we can connect the devices that connects the links of the same type are often called as switches. So switches, normally in the lab also, we have connected for every lab one switch. So each switch used to be connected to other network, so that it becomes very easy. So very easy to maintain, handle. So that is what you call it as, switches. Switches are certainly being used in order to achieve this internet working. And moving further, uh, partially, it's very important to know if two Ethernets, two LAN networks, if you want to connect, so similar networks, if we want to connect, definitely we will make use of bridges. So bridges, we will make use of this, one fellow, Badmash. I'm noting your email IP address, man, Badmash. So you'll see very soon. You'll see very soon the consequence. My dear Badmash, your email is tracked. You will be very soon see the consequence. Okay, a particular important class of switches that generally interconnects two or three networks, similar networks, we call it as bridges. And bridge will connect two or three similar networks. And if you have both the sides, so you have one network, one side, another network, another side, both are LANs. So both are LAN. You just imagine both are LANs. And in order to connect these two, both are similar type of networks. So we use bridge. So bridges we use. So these bridges will connect to similar networks. Suppose one side LAN, another side you have a wireless system. Other side you will have a wireless Wi-Fi system. We suppose if you want to connect, so this is 802.3 and this is 802.11. If you want to connect, you will use the switch, we call it as gateway. So gateways are generally used to interconnect two multiple networks. So there is gateways. We call it as gateways, and certainly they have been used. Okay, so gateways are certainly it has been used, and to move further. So the core job of a switch is to take the packets. The core job of a switch is to take uh, packets that arrives on an input and forwards the switch, forwards them to the right output, so that they will reach their appropriate destination. The main task of switch is to check whether whether the packet which you are getting from one end, it should reach the other end very clearly. So that is what you see. It is the main job of this switches. Switches not only stores and forwards. You observe here, the core job of switch is to take the packet that arrive onto one input and forwards them at the right output place. So for a switch, you have multiple, one input and multiple output. So for a switch, you have one input and there are multiple outputs. So particular packet, suppose it is coming. So this packet which has to go in which direction, in which output line. So whether it has to go in this line or second line or third line. So where it has to go, that is the decision maker that we see switches. And the advanced switches are also called as routers. And of course, switching and bridging. And of course, in the simplest term, switch is a mechanism that allows us to interconnect the links to form larger networks. So this is one very important thing. Okay, in the suppose whenever you want to expand your network, I want to have more and more networks. I want to have more networks. So whenever I want to have more and more networks connected, definitely you make use of switches. So the switching mechanism certainly allows you to create a larger network of networks. So in case of bridge, you are connecting to a similar. In case of gateway, you are connecting or gateway or router, you are connecting to heterogeneous networks. Heterogeneous Wi-Fi network, LAN network, other networks, other different types of networks, maybe fiber optic network, etc., etc., etc. So you can certainly have multiple multiple networks connected using routers. And of course, switch is a multi-input and multi-output device that transfers a packet from an input to one or more outputs. Suppose if you are doing broadcasting, so definitely one packet has to be broadcasted across all the lines. And whereas if you are doing unicast, one input, one output. So if you are doing multicasting, one input and to a selected outputs, we call it as multicasting. And of course, you can see this, switch. You can see this switches. Okay, so it has one input and multiple output. Of course, multiple input and multiple output. And of course, this switch creates a star topology of a point-to-point link, directly point-to-point link. You can certainly have with respect to switch, and we can star topology, and we can establish interconnection of two switches. Suppose I have one switch which is a star topology. Similar type of switch network I can certainly have, and I can interconnect these two so that I can expand my network. Similarly, I can have one more switch, one more star topology, one more star topology, one more star topology, certainly to have multiple such networks. So today, the same way your internet is working. Internet is working in the same fashion. It is an interconnection of multiple switches and multiple computers, multiple networks across the globe. So through the routers, certainly it is working in the same fashion. And observe very keenly, the star topology has several attractive properties. Even though switches are having fixed number of inputs and fixed number of outputs, maybe it's a limited. So which limits the number of hosts that can be connected in a single switch. And of course, single star topology. Of course, if you want to create a large network, what you can do, you can interconnect. You can interconnect, the total number of switches. We can interconnect the total number of switches, across the what we call it as switches. Certainly, you get this large connection of networks. We can connect switches to each other and host using point-to-point, exactly the same way. So the same way when we are having one star topology, another star topology, another switch. So one switch can be connected to another switch as a point-to-point link. So two switches can be connected, interconnected, point-to-point link. So which is enabling extension of two topology, two networks, which is an extension of two networks. So we can certainly extend networks across very large geographical area. That is one very important thing that you should understand. Adding new hosts to the network by connecting to a switch does not necessarily reduce the performance of the network for other hosts that are already connected. One another advantage is if you connect a new computer to already existing network in a star topology using a switch, so it does not reduce the performance. That is one big advantage we have. So it does not reduce the performance of the network. That is one very important thing. So even if you add a new host, it does not impact on any of this one. So people are, that's why they are moving towards the switch based networks. And the switch's primary job is to receive incoming packets from one of the links, and the same thing, it has to be transmitted them in some other link. So this function sometimes referred as switching and forwarding, and in terms of OSI model, so this work is done by your network layer. So your switches work in the network layer. So your switches, routers, bridges, they all work in network layer. So that is one another thing. And how exactly the switch work? So that is one very important thing. Then the question is, how does switch decide which is the line it has to transmit? Anyhow, it has received a packet from one line, and it has to forward it to another line. So, but another line, you have multiple options. Outgoing line is multiple options. How it decides which is the right path, which is the right path? So for this, what happens for every switch, it maintains table. It maintains a table. So based on that table, so what happens? It will take a decision where this packet has to be, sent. Again, through which output line it has to be sent. So the general answer is that it looks at the header of the packet for an identifier that it uses to make the decision. And of course, this is done based on the a table. So the details of how it uses the identifier vary, but there are three common approaches. So for this, the first approach is datagram approach. How exactly it will forward the incoming packet to outgoing line. So this entire concept, we call it as switching. Switching is the process of getting packet from one of the input line, and it has to forward it to the output line. So that is what you call it as switching. And switching, it has three types. The first type is datagram. Second type is virtual circuit. So observe datagram, we have already seen UDP, which doesn't have a connection establishment component. So it is a connectionless. So you need not have to establish a connection with respect to datagram. So that is the first approach. So it will never establish a connection. It simply transmits. So that is datagram approach. Second one is virtual circuit. It prepares a virtual circuit and it will send. Third one is source routing. Source routing, now it is very less common. These two, other than these two, but it does have the same useful application, but they'll be very less used. But this is also one of the approaches for switching. This is also one of the types of switching. So switching is a process of getting a packet from one of the input line and decide which line it has to be transmitted. So using a table, we call it as switching table. So switching table, sometimes in other textbooks, they have also written it as routing table. The switching table or routing table is maintained by all the switches in the network. So that contains the details about the connections which node is connected to which switch, and what is their IP address, what is their MAC address, that is physical address. All those information will be stored on this particular switch table, switching table. So when we take up switching, so there are three types of switches. There are three types of switches. First type is datagram, second one is virtual circuit, and third one is source routing. So first one, datagram. What is exactly datagram? The idea behind datagram is incredibly simple. So what happens, there is no connection established. You just include every packet enough information to enable any switch to decide how to get it to its destination. So just simple. There is no acknowledgement, there is no connection establishment. Only it has to be transmitted. That's all. It has to be transmitted. And consider an example network in the figure. So we'll see the figure here. So you can see in this figure, so probably in this figure, we have considered the example network illustrated in this figure, in which the hosts are A, B, C, D. A, B, C, D are the hosts. You can see A, B, C, A, B, C hosts, A, B, C, D, like that, so on. Many hosts are connected. So, of course, you can see for switch 1, 3 nodes are connected. Switch 2, there are only one node. There are 2 nodes, in fact, 2 nodes. For switch 3, so you have 3 nodes connected. You can see, and it is connected. And between one switch to another switch, there is a point-to-point connection. See, 1 and 3 is connected. So between switch 2 and switch 3, you have a connection. And remember, this is a 4-bit switch. 4-bit switch means only 4 computers or 4 hosts can be connected. You can see for a switch 1, in port number 0, host D is connected. Port number 1, there is a connection to another switch, that is 2. Port number 2, it has connected to host A. Port number 3, it has connected to host C. Same way, 0 is connected to host 0 is connected in the switch 2, it is connected to switch 3. 1 is connected to F, 2 is connected to E, and 3 is connected to switch 1. Same way, here also the same way. For switch 3, 0 is connected to switch 2, 1 is connected to host G, 2 is connected to host H, and 3 is connected to host B. Now each switch maintains a forward table. It maintains a forward table. So there is a forward table, or we call it as a switching table. So what is there in this? Which will have 2 components. As you see, it has a destination and it is having a port. Same way, here also there is a forward table. It is also called as routing table. It is also called as switching table. So this is a forwarding table. And for every this one, so every switch maintains this forward table. And this forward table is used to decide how to forward a packet from one host to another host. How exactly it has to forward. So that is one thing that you should understand. So this will be maintained, the forwarding table will be maintained at every node. Now, this is an example forwarding table that is maintained at switch 2. You can see forward table for switch 2, destination A. So from switch 2, how to reach A? A you can reach through port number 3. Yes, you can reach. So you can reach from port number 3, switch 1. Switch 1 is attached to host A, C, D. So A, C, and D. You can see they can reach through 3, port number 3. And port B can be reached, host B can be reached using port 0. Yes. Through 0, you can reach here. and from here you can reach, yes, 0. A, B, C, D, E. E is can be reached through host 2. So yeah, port number 2, yes, port number 2 directly E can be reached. F can be reached using port number 1, yes, using port number 1 F can be reached. Fantastic. Next, G can be reached. G, it is attached to switch 3. So in order to connect to switch 3, you have to go through port number 0. Yes, from 0, it will forward it to switch 3, and through switch 3, it will G is connected. And H. So you can see it is having all the information about all the nodes that are there in the network, along with their port numbers. So whenever it has to pass packets to particular host, it knows through which port number I had to send it. So the outgoing line or incoming line are connected to the switch through ports, and ports are the deciding links. Ports are the deciding links. Now let us look at further. So an example of which is depicted in the picture, yes, we have written. This is the partial table showing the forwarding table at switch 2. The same thing I have explained earlier. So whatever that is there in switch 2, and of course it is written here. Same way switch on also maintains a table. Switch on also maintains a table. And switch 3 also maintains a table, similar table like this. So it has all the nodes and how to reach all the nodes. So in the examination, what they do, they'll give a diagram like this. They'll give a diagram like this. So network diagram, and they'll ask you to write the forwarding table. They'll ask you to write the forwarding table at port number at the switch number 1. So switch 2, you can write the same thing. Switch 1, so you have to write same thing. A, B, C, D, E, F, G, H, up to H, it is there. Okay, A you can reach port number 2. B you can reach. B is present in this. So B it has to go through this switch 2. So the outgoing line B can be reached port number 1, and C you can reach in port number 3. D you can reach in port number 0, and E you can reach to again port number 1 only. Through 1 only you have to reach. F also port number 1. G also port number 1. H also port number 1. Of course, port number 1 is the outgoing line. So port number 1, it has to reach to the destination. Here in the intermediate switching node, here again it will take decision and it will transmit. So that is there. So every node connectivity is written in your forward table. So forward table is maintained at every switch. That is the important thing that you have to understand, right? And there are some characteristics of datagram method of networking. Okay, first one, the host can send a packet to anywhere at any time. It can send packet to anywhere, anytime. Since any packet that turns up at a switch can be immediately forwarded. Based on the forwarding table, it will be immediately forwarded. This is the reason datagram networks are often called as connectionless. They'll never establish a connection before they transmit. So that's why they call it as connectionless. So based on the forwarding table, it will just forward it. This contrast with the connection-oriented network. What happens to the connection-oriented network? It will establish a connection. That's one very important thing. So it needs to establish a connection. That is in the case of connection-oriented. Whereas in the form of data-oriented, datagram type, there is no connection. So a packet will be sent to the next switch, and next switch will decide where it has to, in which port it has to go out. So it will move out of next switch, and finally, like that, every switch will forward, forward, forward. Finally, it reaches the destination. So this is one important characteristic that you should have with respect to datagram. Datagram is connectionless. It will never establish a connection. When a host send a packet, it has no way of knowing if the network is capable of delivering it, or if the destination host is even up running or not. Whether destination host is available, running or not, it will never bother. It will just forward it to the next available link based on the routing table or the forwarding table. Yes, based on the table, it will forward. And each packet is forwarded independently of the previous packet that might have been sent to the same destination. That's very important. So there is no the same route guaranteed. Route may vary for packet to packet. Thus, thus two successive packets from host A and host B may follow completely different path, perhaps because of the change in the forwarding table, and also change in the link, change in the what do you call it as change in the network, change in switch. Sometimes switch itself, it will goes down, so it will look for an alternative path and makes the packet to reach at a different route. So at a different route, it has to reach the destination. So that is the job that it is doing. That is what your switches are doing. Switches main job is store the incoming packet, forward it to the appropriate port so that it reaches the destination. And switch or link failure might not have any serious effect on the communication. If it is possible to find alternate route around the failed switch, yeah, certainly once the switch fails, automatically what happens? The other switches will automatically update the forwarding table accordingly, and forwards the incoming packet to the appropriate right what you call it as the port. So when it is sent in right port, so what happens? There will not be any problem. Automatically, you can certainly increase. You can certainly establish the connection. You can establish the connection. Okay, you can establish the connection to the forwarding port. So you can send the packets based on the alternate route. You can reach the destination. So that's all for today's class. Next class we'll discuss about a virtual circuit, how to work with a virtual circuit, how virtual circuit will exactly run. And today's class we understood how forwarding table is very, very important. And in forwarding table, it maintains the names of the nodes plus their port number that is connected. So that is virtual circuit we'll see in the next class. That's all for today's class. Thanks for attending. And CR, you can certainly note down there were 38 students when I started, and in between due to
Yes, sir. Yes, sir. It was 39, sir.
39, yeah.
Yes, sir.
You can give attendance to all 39 students. Okay. So
Okay.
in between, due to network issues, many have missed. Okay. No problem. Yeah.
Sir, actually, if you had texted me like,
Hmm.
is whether the meeting is locked or what?
Actually, we have been already getting instructions from higher ups and also various government agencies that we have to start the meeting as soon as we start the meeting, within 5-10 minutes, we have to log the this one, the meeting, or else what happens, there are chances that, our entire data, entire network may be hacked. Okay, so that is a serious
Yes, sir.
issue. I think we have to lock. So I will wait every class. I'll wait for first 10 minutes. So people who can join within 10 minutes, okay, I can allow. And today also somebody was playing around. Badmash, some name was there. So I just noted his IP address. I'll immediately report to the cyber police. So I have the mail ID and this one. I'll immediately report along with his time of recording. So this session is recording. So it is recording. You can see the session is recording, and I will show his nonsense thing that he has done over this the video camera. So everything along with his IP address I have captured. I'll report definitely to the cyber police. So it is a warning for others also. So once we do like this, other people will get at least some fear. And India is very much, taking care of cyber security. So cyber police in Bangalore are very active. I'll definitely report this to the cyber police. Okay, that's all for today's class. So, and every class, please see that those who are present, you should present within 10 minutes.
10 minutes ಹೋಗ್ಬೇಕಂತ ಇಲ್ಲಾಂದ್ರೆ ಲಾಕ್ ಮಾಡ್ತಾರಂತೆ. ಎಂತ ಹೇಳಿದ್ರು 10 minutes ಅಷ್ಟರಲ್ಲಿ ಜಾಯಿನ್ ಆಗ್ಬೇಕಂತ ಮೀಟಿಂಗು, ಇಲ್ಲಾಂದ್ರೆ ಲಾಕ್ ಮಾಡ್ತಾರಂತೆ. ಅಂದ್ರೆ 10 minutes ಅಂದ್ರೆ ಲಾಕ್ ಮಾಡ್ತಾರಂತೆ, ಯಾಕಂದ್ರೆ ಡೇಟಾ ಎಲ್ಲ ಹ್ಯಾಕ್ ಆಗ್ತಿದೆ ಅಂತ ಕಂಪ್ಲೇಂಟ್ಸ್ ಬರ್ತಿದ್ದಲ್ಲ. ಅದಕ್ಕೆ ಮೀಟಿಂಗ್ ಸ್ಟಾರ್ಟ್ ಮಾಡಿ 10 minutesಗೆ ಲಾಕ್ ಮಾಡ್ತಾರಂತೆ.
Yes, Lavanya, you are correct. So that is the reason we are locking after 10 minutes. So please tell your friends. CR, if anybody is unable to attend today, or if they have messaged you, so you can certainly give attendance. Yeah,
sure, sir. I'll do it.
So we'll consider only for today's class. We'll consider those students. I think how many of your friends have messaged that session is locked? Like if you add some more, I think 4 or 5 students.
Actually, it was 3 people, sir.
3 people. So
including them, the participants count is 39, sir.
Oh, including them. Okay. Okay, we'll make one thing. I'll announce it in the group. Okay, 40. Okay, we'll see. Next class onwards, within 10 minutes they have to come, or else it is not possible. Okay, because of this cyber serious issues, we have to be very careful. And anybody can join. And this one, Zoom is not asking for password and all. It is never asking password. No security at all. So we should be very careful. Okay. So anyhow, we'll see in the next upcoming classes. Is there any changes, alternates that are required? As of now, we can go with Zoom by locking the session. Yeah, Megha, you want to say something, Meghana?
Yes, sir. Can we have the second module revision class, sir, like in a day or something?
Okay, definitely. So if somebody is missing, see one very simple thing, Meghana, I would like to tell. All the class recordings are available in this particular website. So I have already shared. So it is available in this website. I think revision concept. Okay, we can have revision. If you have any doubt, see, if some people have doubt, you can certainly call me. I'll I'll teach them. All the class recordings are available in this particular website. Every day's video I'm putting. Okay, so I think revision is not at all necessary, I believe. In case if any student wants a particular topic to be rethought, for that student or a group of students, I'll conduct separate class, maybe some other free time, I'll do it. Okay, I think that's the purpose, Meghana.
Hope you understand, right?
Yes, sir.
Huh? Yes, ma.